Hi, this is Colby Bannon, and this is my Makeup Lab 8. For the first problem, we look at comparators, and I built the circuit for a comparator, and what the comparator does is switch from two states, a low and a high state, based on the V input. So I went ahead and made this circuit, which I designed here, and the inverting input is set to 2.5 volts through a voltage divider, and the non-inverting input is set to a potentiometer, so it ranges. So I can go ahead and demonstrate. Right now it's at the low state, and as I turn the potentiometer, it switches to the high state. And you can look at this graph and see that it begins down this lower state and then jumps here at a very steep slope to a high state. So it looks like a step function, but it's not quite. So here's my exercise 1, where I derive the gain of the non-inverting amplifier circuit. To do so, I applied Kirchhoff's current law at node A, which I labeled, and performed the analysis, and then simplified terms to determine what the non-inverting amplifier looked like. For exercise 2, my Arduino code is pretty simple. I simply set up the pin modes for each of the different analog read ports, and then printed a string that displayed each of the values, which is sent to processing. My processing code is similar to Lab 5's. I did change the legend to match the different values of V, and then when I am pulling info from the Arduino, I defined 4 different characters or integers, values that are pulled from the strings, and then noted like I did the type conversions for each to make sure it fit nicely into the window, and created ellipses for each to plot the data. I've built my unity gain amplifier circuit, and the output on processing looks like this. And as I change the V input with the potentiometer, you can see that it follows, it's also a voltage follower. The amplifier follows the input voltage, but then as it reaches around below like 1.7 volts, it drops, it can't go any lower than that, so the amplifier is saturated at that point. But as soon as it goes back up, it follows it again up to about 5 volts. So for exercise 3, I built an inverting amplifier on my circuit. In order to build this circuit, I knew I wanted to get a gain of -10. So in order to do that, I designed the circuit like this and chose values of R1 and R2 to be 1,000 or 100 and 1,000 respectively. And then that gain is determined by -R2 over R1. Go ahead and look at my processing code, pull it up. So at 0, the offset voltage shows up as 2.5, and the Vin, as Vin is increased up to and past that offset voltage, then Vout inverts back down to 2 volts. And it does the same as you cross that boundary again, turning back the potentiometer. So you can see it runs between 2 states and is inverted after it passes that offset voltage. For exercise 4, I derived V out for the integrating amplifier op-amp circuit. To do so, I set up, I looked at the Kirchhoff's current law at node A and set the currents equal to each other, and the current of the capacitor is equal to C over dt. I know that VA is equal to 0 and that VC is the same as -V out. So plugging those values in and integrating gave me this relationship for V out, and then plugging in the numbers given gave me -21.28 VNT is equal to that V output. I have constructed my circuit of the integrating op amplifier, and here is my processing output. Right now it's at 0 volts. When I change the V in and increase it. Once it hits this offset voltage, then the capacitor charges and the equivalent resistance goes up, dropping the voltage, the output voltage down to around 1.7. Same thing if I go down and past that point, then the capacitor discharges, resistance goes down, and the output voltage goes up. Hi, I'm Colby Bannon, and this is my Lab 9 demonstration video. First, I'm going to demo my circuit running, and then I'm going to go through the Arduino code and processing code behind it. So to begin, I can go ahead and open the serial monitor on my Arduino program, and then the circuit is waiting for me to turn the potentiometer a certain distance. So once I get that distance, it asks me, guess which LED will light up. So the user can then input the guess. In this case, I'll go with 3. And then the circuit waits for me to rotate the potentiometer to the final position. And the game begins. So this is the first LED, second, and it goes around to 8. So it landed on the first one. So that activates my motor since I lost and gives me a thumbs down. And on the screen, it was going through each LED it lands, and that ends up landing on 1, tells me my guess, and says that I lost. Here's my Arduino script for the project. To start and set up, I set up the pin modes corresponding to each LED. I then use random seed and serial begin. Random seeds just make sure that I get a more random number than I normally would for each run. And I've set up the code so that it's continuous. It can run the game as many times as you want after only uploading once. To begin, it initiates the potentiometer where it's reading the input from the user and creates a while loop that holds the game from starting until the potentiometer reaches a certain point, in which then once it does reach this point, it will ask the user to input an LED guess. And from that point, it enters another while loop that waits for the user to enter, and then goes down and waits again for the potentiometer to be rotated to the final position. And that's when the game begins. This initiates the winning number, random number from 1 to 8. And then going through this first for loop, goes through and blinks each LED fast at one single speed 9 different times. And I do that by a nested for loop and just write the individual pins, each one, on and off. And then the second nested for loop I have, this corresponds to blinking the lights slower and slower each time. So I do that by setting a speed 1. The speed 1 begins at 50 and then increments throughout each time. It adds 10 here. So each time an LED is blinked on and off, it'll be slower and slower. And the final one, this is when I implement landing on the winner. I do the same thing, but this time I increment the speed at an even higher amount, meaning that it goes even slower and slower after each LED is turned on and off. Finally, once it recognizes that the winner is the final I in the loop, that turns and blinks the winning LED 5 times and leaves it on for 3 seconds. Now this then sends to the serial monitor, explaining to the user what their original guess was and if they won or not. Based on if they won, that dictates the motor movement, where I have attached the thumb to the motor and I simply put the motor to one position if they lose and a separate position if they win. So if they win, I'll set it to this position using PWM, and if they don't win, then it does this separate position, just opposite 0 and 180 degrees. But then either way, it resets it to the 90-degree position, which is the regular position, thumbed in the middle. So I'll demonstrate the circuit one more time, this time on a winning value. And to do so, I change this one line of code where I rig the game to land on 5, so I can guess 5 and ensure that I get a winning value. So I go ahead and turn this and then enter 5 into the serial monitor. 5, control enter, and then begin the game. So it should land on 1, 2, 3, 4, 5. There we go. And this corresponds to the motor giving a thumbs up. Now, in order to run my simulation on processing, I comment out this block of code in my Arduino, which is using the display or the serial monitor to ask for the user to input. But since we're using processing, I can't have the serial monitor open, so I instead have the user input it onto processing. So I go ahead and close this out and then open up my processing script and run. And now it brings up this figure. So it's asking for the user to enter a guess. So I can then type on my keyboard, let's say 6, and it prints that in the top of the screen, and it waits for the user to turn the potentiometer. So I go ahead and turn it, and this simulates what is happening on the board at the same time on the screen. All right, and this lands on LED number 5, and that is printed on the screen. I lose, and this gives me a thumbs down. Again, that is the figure I am using. And now to go through the processing code, I go ahead and use similar code we've been using throughout the semester to import processing the serial from our Arduino. And in setup, I just set up the window size and open the ports up, and then set up the background color. And then in order to make this figure here, each of the red circles are completed here, and the numbers within the circles are completed here. This is the point where I ask which key is pressed, and if a certain number is pressed, then it will print in the upper screen. So it only allows the user to print 1 through 8. And going down, this is where it is reading from Arduino and the serial monitor. So it's taking all of those entries, and if I go back to the Arduino code, now the code is actually creating a string whenever it's inside the for loop from 1 to 8, and that is that LED position. So it's constantly printing 1, 2, 3, 4, 5, 6, 7, 8, and as it goes through each iteration, it's continuously printing those out, which will give me, since I'm sending those to processing in this for loop, and this last for loop, I can access those in processing, and that can simulate me blinking the ellipses a different shape and color, which is what I do lower in here. So, well, this is displaying the winner right in the middle of the figure. This makes the winner, and then fills it with the text of X, which is made from the integer of the string. And you go down, and then in order to make it like actually say 1, 2, 3, 4, 5, I'm printing a separate circle over in between iterations, so it's readable. And so yeah, this displays the number when blank. This sets the color of the blank, and then this is what's actually blinking the red LEDs that are simulated. So going through, if X is 1, it'll blink this one, and then so on. And yeah, that is my processing simulation of my Lab 9.